Hello, my name is Rob Reynolds. Welcome to Business Calculus, Chapter 4, Section 3. Today we're going to be learning how to take the derivative of an exponential function. Specifically, we're going to be looking at, we already know how to take the derivative of a power function by multiplying 5 times the 1 and then decreasing the exponent. What we haven't looked at is this scenario, taking the derivative of e to the x. And so I'm kind of do a play on word, and it doesn't really matter what this x is, but the derivative of e to the x, or e to the cow, is just e to the x, and then you take the derivative of that x. Let me give you an example here. This is called the, maybe you remember, natural logs have a base e. So we're going to look at these functions with e's in them. There it is. If f of x equals e to the x, then f prime x equals e to the x. And there's a nice little proof for this, but to do the proof of this, we actually have to go back to f of x plus h minus f of x, if you remember, all over h, and take the limit as h approaches 0 to actually do a proof. So I've done that here for you. Remember, we've let delta x equal h just to kind of simplify things. If you're interested in this proof, you can pause the video and look at this right here. But the point is after all of this, you get e to the x. So if you just remember that the derivative of e to the x is e to the x, we're good. Now you may say, well, wait a minute, I thought you said there was something more. Well, there is. There's that dx, which really just goes to 1, and then nobody ever writes it. So when do you have to worry about that? Well, that's kind of like when the chain rule comes in. So that's what this thing was here. So if you take the derivative of something like, I'll make something up, 5x cubed, and then square it, that's the same thing as 2 times the 5x cubed, decrease the exponent by 1, times then the derivative of this 5x cubed, which is 15x squared. And of course, you could simplify that as well. So just reminding you a little bit about chain rule here. That's when this, so this is no chain rule. There's a dx, which nobody ever writes because that's just a 1. But here's that chain rule. If it's something other than just an x, we'll call it a u, then you have this du dx. So again, my play on this is the derivative of e to the cow is e to the cow. You just write that is always the same as this. You just have to remember to take the derivative of the little baby cow, which sometimes we just call the derivative of u. So here's our first example. If you haven't already, go to Blackboard and print off the worksheet that's there, and you can follow along. This says find the tangent line, so that refers to finding the derivative, and of course the derivative of e to the x is simply just e to the x, and then evaluate it at the points that are given. So there's my x, and there's an x. We'll call that x sub 1. This is an x sub 2. So there's a couple problems. Let's go, the derivative at 0 is 1, and then the derivative at 1 is e. And here are worked out solutions. Remember, that's just the slope of the tangent line. Here's where you have that du business. Remember, the derivative of this in part A, the derivative is itself. Whatever it is, that's the derivative. But then you just have to remember to take the derivative of this guy up here. So the derivative of 2x is 2. So the final answer is 2e to the 2x. For part B, the derivative of this is itself. So we just write that down, e to the negative 3x squared. But then you have to remember to take the derivative of the u. So I'm doing the derivative of e to the u du, or the derivative of e to the cow. There's the cow. And then the derivative of that is negative 6x. And so the final answer, I would probably just write it as 3x squared. Again, this would be a good part for you to pause the video and see if you can do part C before I do it. Now remember, the derivative of a constant, that 6 is just going to float out there. So don't even worry about it. Just worry about taking the derivative of e to the x cubed. And of course, the derivative of e to the x cubed is e to the x cubed times du, which is 3x squared. So final answer, 18x squared e to the x cubed. And then part D, the last problem, the derivative of e to the negative x is e to the negative x, but then times the derivative of negative x, which is just negative 1. So I'd bring that out front. Here are worked out solutions from the author. Looks like we did good. And here are some more problems that you can practice. These get a little bit more complicated. I'll do a couple with you. In A, remember, e is not a variable, so this is kind of a tricky problem. E is really something close to like 2.7, 1828, 1828, 45, 90, 45. You can memorize more decimals. It's like pi. It goes on forever. But it's a number. And the derivative of 4 is just 0, so the derivative of 4 times this 2.7, 1828 is still just 0. In part B, this was something similar that we just did. The derivative of 2x minus 1 is a 2, and then write down itself. C, you're going to have to do the product rule. This is that 1d2 plus 2d1. I'll let you try that. I think the final answer is going to be x e to the x plus e to the x. You might try the quotient rule here, low d high minus high d low, but I wouldn't. I would do a quick little rewrite. And then I would try to take the derivative of that. Remember, that constant could just pop right out, so don't even worry about the 1/2. The derivative of e to the x is e to the x, and the derivative of negative e to the negative x is, well, that would be the derivative of that guy is just a 1, excuse me, negative 1, and that the derivative of negative x is negative 1, and that changes this negative to positive e to the negative x, and I would probably stop. There's the final answer. You could distribute the 1/2 if you wanted, but I'm done. This one I would probably do low d high minus high d low. So low, the derivative of e to the x is e to the x. So low d high minus high, and then the derivative of low is just a 1 all over low squared. And you might even factor out an e to the x. And the last one looks like this problem we've already done, and then all you have to do is take the answer for C, which is here, and subtract off, and the derivative of e to the x is just e to the x. So the answer is just going to be x e to the x. So again, I went through those kind of fast, but I think there are worked out solutions. Here are some, and here are others. Again, you can go to Blackboard and see a PDF file of all of this as well. Okay, and good golly, this goes on forever and ever. Pause the video and see if you don't get that. All right, so this again mentions the word this tangent line, and that means find the derivative and then plug in the x value to find the slope of that tangent line. And then we'll write the equation y equals mx plus b. So I'll start out with number 19. The first thing we need to do is find the derivative of this thing, and that's the product rule. So I would do 1 d2. That's not d2. Let's try that again. 1 d2, the derivative of that is negative e to the negative x plus 2 d1. And I would probably try to clean that up. And actually, it's not really necessary to clean. Maybe I'll just plug in a 2 here. So this is 4 negative e to the negative 2 plus e to the negative 2 times another 4. So that's negative 4e to the negative second plus 4e to the negative second. And so the derivative at 2 equals 0. And if that's true, then I've got a horizontal line. And that horizontal line is just y equals 4 over e squared, because that's the y value. That was an interesting one because everything fell out. Let's try number 20. I would go find the derivative of this thing, which is low d high, which is just a 1, minus high d low 2e to the 2x all over low squared. Let me write that as e to the 4x. Then I'm going to let x be 1. And to find the slope, so y prime 1 is equal to e squared minus 2e squareds over e to the 4th. So this is negative, let's see, 1 minus 2. Negative 1 e squareds over e to the 4th, which is rewrite the base and subtract the exponents. 2 minus 4 is negative 2. So if that's the slope, I'll go write the equation y equals mx plus b. Hoi joy joich, this is tough. So there's the y value, which is 1 over e squared is equal to the slope. I'm going to write him as negative 1 over e squared as well, because that's what happens with this negative exponent, x plus b. Oh, x is a 1 because of this guy. And so then I add that to both sides, plus 1 over e squared plus 1 over e squared, and I get b equals 2 over e squared. So now I've got slope and the y-intercept, and I can write the equation for number 20 to be y equals negative 1 over e squared x plus the b, 2 over e squared. That's ridiculously hard. So there's number 19. Did we get number 20 okay? Looks like 19's okay. Horizontal, that was just the y value. I think we did that. Ooh, okay. Does that equal the same thing? Let's see. Y is equal to the slope, negative 1 over e squared x plus 2 over e squared. Yeah, they just wrote it differently than I like the way they wrote it, but you don't have to. Our answer was good. So try 21, try 22. Here are the solutions for this. Remember, for 21, you're going to have to do the chain rule. The derivative of the outside, so y prime, right down the inside. Don't forget to decrease the exponent 1, times the derivative of the inside, e to the 2x plus 1, which this is 2e to the 2x, and the derivative of 1 is just 0. So this 2 can get multiplied by that 3, and I suppose I've got a 6 somewhere floating around. Let's just jump. Oh, and then let's see, for 21, I think we were supposed to, oh, there it is. It just didn't copy, I guess. That we're supposed to let x be 0. So after you find the derivative, let's let x be 0. You know, they didn't even get to the 6. They just kind of left this in this form right here, this guy. And if you just let x be 0, then the slope turns out to be 24. Is that true? So 3 e to the 0, because 2 times 0 is 0, plus 1 squared times 2e to the 0. Well, e to the 0 is a 1, so 1 plus 1 is 2 squared times 2 times 1. 4 times 3, 12 times, that did work. God, I didn't think that was going to work. But I'm glad we got 24. That's my slope. And then you go write the equation. Now, they're using this y minus y is equal to the slope, x minus point slope form. I always just go to y equals mx plus b, but you're welcome to go either way. If you do this y equals mx plus b, you just plug in for y, slope, and x, because that's what's given, x, and then you just solve for b. Either way, you always put the final answer in this form. So try 22, pause the video, it's similar. And for 22, we're going to plug in the point 0, 1. It didn't show up on this slide, but after you take the derivative and plug in a 0 to find the slope, and I think the slope for this one turns out to be -8, then you go back and you write the equation y equals -8x plus b and solve for b by plugging in for x and y. And looks like you'll eventually get -8x plus 1. You usually don't want to ask a math teacher about when is this ever going to be, or when am I ever going to use this, because then that means I have to show you some applications, and that means word problems. So here's an example where you may use this in business. So here's a function, yada, yada, yada. And it says show that the lowest point on the wire is between the two poles. So you're going to take the derivative and actually find the minimum, and you do that by taking setting it equals 0. So you guessed it, you got to find the derivative of this thing. So work on the derivative of this. I think this turns out to be close to this, and then set that derivative equal to 0 and see if you can't solve. Then, since we're going to find a critical value, right? After you set it equal to 0, you get x is equal to some critical value, and I think that critical value is a 0. Then you're literally just going to use these endpoints. Do you remember how to do that? And just verify that it really is the lowest point. So I would check f of the first endpoint, the far left endpoint, 30, f of the critical value, which I believe this will turn out to be 0. We'll check that in a minute. And then f of 30. And you really just go back to the original function and use your calculator and just evaluate at those points. Either you could do table setup, and then sure enough, that's the minimum. That is the lowest point. So here's how to find that derivative. And here is when they set it equal to 0. And sure enough, x does equal 0. So we know that that's the critical value. And then you run your test. So there's the picture of that. And oh, there's their 3 tests that we did too. Good, good, good. All right, so another application would be finding the maximum revenue. And if you remember, revenue is defined as XP. So, and in this case, X is X, but P is given. So the first thing I would do is just multiply that function by X, and then that's revenue. And then once you have revenue, we're trying to maximize it. And to do that, we take the derivative of that function. So you go find the derivative of this thing. I think it turns out to be around 56x e to the, this is ridiculous, lots of zeros, times negative 0.00012, these are all zeros, plus e to the negative 0.000012, x times 56, that's the product rule because there's the first term, there's the second term, so I did the 1d2 plus 2d1. Simplify that, and then plug in to find, let's see if that's what, yep, there's there. Set it equal to 0, find the critical values, plug in the x value where it was the max, which is evidently 83,333 units, and find the y, which is how much it's actually going to yield. And that's the p, but then the revenue is this function and turns out to be that max revenue. And here's some graphs that I've actually, punched into the calculator. You might have to change your window. You can see my min and my max for x's and y's have greatly been changed, so I can actually just kind of check for that. Last little concept here is the normal probability distribution or density function. And you guessed it, they're going to give me a function. This list just looks horrible, but they're going to ask you to find, again, the max and the min of this thing. So you're going to take the points of inflection as the second derivative. So the first derivative is here, and then you're going to take the derivative of that derivative and set it equal to 0 to look for concavity. And when concavity is changing from up to down, then you've actually located a point of inflection. So I'll leave that one for you. I think the answer turns out to look like this. Looks like the point of inflection is at a 1. But you can do the math for that and make sure that actually does happen. All right, I hope this video was helpful. If you have questions,